Hello.
So as I was saying that I work with Cisco. My name is Laksh once again, and if you want to connect with me over LinkedIn, you can do that as well by searching the name Lakshmikant PS. So I work with Cisco, and I have 9 years of experience, and majorly with routing and switching. I have completed my CCNA, and I had also completed back then. I had completed my CCNP route and CCNP switch. uh, T-shoot I could not clear by the time I started working on CCNP troubleshooting on the routing and switching side. The Cisco had revamped their certification, and I could not write the T-shoot. But however, there was an advantage where I got, which was my CCNP routing and switching got converted to CCNP ENCORE certification, so I didn't have to complete T-shoot one more. So I got the ENCORE certification. Along with that, I have already completed CCNP SP core, that is service provider core. So and I have a specialist certification in both CCNP ENCORE and CCNP SP core. I gave CCI last year, CCI service provider core last year. Unfortunately, I couldn't clear it, and I am going to attempt it once again in the month of April this year. So that is from my side, and just to know a bit about yourself, I just wanted to know if there is there anyone who is a fresher and who has joined this session. I just want to give me a hand, a raise of hand. That's all. Is there anyone who is a fresher here, or has less than 3 years of experience, 3 or 3 years, or less than that? Please raise your hand. Uh, all right. So there are three people, okay, who have 3 and less than 3 years of experience. Okay. No problem. So what I'll do is the way I explain about the system, about the certification is not the usual way. I just explain based on the curriculum that you'll see in the ENCORE and NRC system. So all of you have already enrolled in the CCNP, ENCORE, and NRC course, right? So before we even enter into the course, um, let's first of all understand what is enterprise. Okay. So what do we know, or what do we understand by the word enterprise? Okay. So enterprise in generally, it's no any um, group of in any company in itself is called as an enterprise. Like my company Cisco is an enterprise in itself, right? It's a company, it's an enterprise. Google is an enterprise. Our shopping marts, like I have a Star Bazaar or a D-Mart nearby, that in itself is an enterprise. Okay. So when we talk about enterprise network in the terms of computer networks or networking, what does an enterprise mean? So in an enterprise, so assume this as an enterprise. Okay, this as a company. Okay, you can assume this as a company. Okay, one big company, and this is just an overview of how the company's devices will be connected. So any enterprise will have different devices, like you can see a monitor, you can see routers, you can see telephones that are connected, you can see different networking and switching devices that are connected in that are interconnected. Okay, but as a user, you are a user, right? As a user, what do you see? You just see the device that you are currently on. Like if you're sitting on in front of a desktop, you will see only your desktop that is connected, and you will also see many other desktop that your friends are working on, right? But then these desktops are connected through a wire, right? They are connected through a wire, and that wire is going somewhere. and that's all you know. Okay, you do not know you do not have the visibility beyond that. Okay, so when we are doing our encore and NRC together, right? What we will be looking into is that what goes beyond your connectivity of your desktop. Okay, so let's start small by small, one by one, step by step. Okay, so the first thing that you will always see, or that is not visible to you, okay, in an enterprise structure, is that all your devices, be it phone, be it your laptop, be it your desktop, be it your teleconferencing devices, anything. Okay, and the example that I'm giving is from a company point of view and not from the devices that are connected inside your home. Okay, so the examples that I'm choosing is from a company's point of view. So all these devices that you see inside your work location, all right, they are, what happened is they are basically connected. Like here, this is just an visual representation. They are connected to a switch. Okay, all of them are connected to a single switch. Right now, this single switch is called as the access layer switch. Is called as the access layer switch. Why is it called the access layer switch? It is called as an access layer switch because it is giving an access to the devices that are connected to it. And it is given an access to what? It is given an access to connect to the internet or intranet. Okay. Now, that is one. Now, inside this, it's not, if your company is a big company, if your company is a big company, what it might look like is, let's assume that this particular is from the first floor. Okay, is from the first floor. Now your company has many different floors. Probably your company is a 10-floor company. Okay, so not just this, you will have different access layer, you will have different, sorry. All right. So what it might look like is your access layer. Okay. Your access layer probably might look like this, where this is for the one at the bottom is for the ground floor. The one at the middle is for the first floor, right? This is for the ground floor. This is for the first floor, and this one is for the second floor, right? Now, what you might not see is that these different switches inside your ground floor itself would be connected to each other. They will be connected to each other. All right. Now, if you want, that your you are sitting on the ground floor and you want to talk to one of your teammates who is sitting on the second floor. So all these switches should be able to communicate, right? They should be able to pass on that information to the person who is sitting on the second floor. Now, how can we achieve that? Okay, so obviously the switches should be able to do that, where they should be able to forward the data. Okay, they should be able to forward your request to go to the second floor, right? Forwarding of your request should be done by the switches, right? Now, along with these switches, what is happening is that these switches also should be able to control the kind of traffic that should go from one end to the other end. Okay, now for example, when I'm saying they should be able to control the traffic, I mean that not every user not every user will be allowed Not every user will be allowed or will be a part of the same team. For example, you are part of example HR team. Okay. And there is another person who is a part of the IT team. Okay. Now, in the access layer, it is not necessary that the HR team, right, whatever the message the HR team is sending, right, it should go to the IT team, right? And what we do is in your access layer switch, in your access layer, we give different VLANs, we give different VLANs to the different departments like HR or IT, so that the message that an HR is sending reaches only to the HR team members. The message that is being sent by the IT guys, they are reached or they are received only by the IT team members. That is the work of VLANs. So we will also study what are VLANs in your enterprise network. Now, along with these VLANs, right, as I was saying, you have multiple switches that are connected to each other. There are multiple switches, just like in this diagram, you have multiple switches that are also connected to each other. And because, why do we need so many switches? Because your company is so big that not all the networking devices can be connected to one single switch. So you need multiple switches that are connected to each other so that you can expand your network. So if I give this in a diagrammatic format, this is your PC, and just not just one PC, there are multiple PCs, right? And all of them are connected to one switch. This switch is called as the access layer switch, right? Then, as I was saying, there are not only one access layer switches, there are multiple access layer switches, where in turn these access layer switches are connected to multiple devices. Okay, multiple end users. It can be a PC, it can be a printer, it can be a server, it can be an IP phone, anything. Again, these switches are then interconnected. Okay, so these switches are interconnected. Now, if the switches are interconnected, okay, if the switches are interconnected, then there should be a mechanism where a layer 2 loop is created. There is a 100% chance that there is a layer 2 loop created. What is a layer 2 loop? So if you have multiple switches connected like this, okay, I'm just taking an example of three switches. If these three switches are connected together like this, there is a high chance that there will be a layer 2 loop created. When I say layer 2 loop, I mean that if a packet or an information is sent out by one of the switches, it will be sent to the other two switches, right? And the packet is never ever going to reach its destination and keep on circulating in between these three switches forever. There is a high chance of a layer 2 loop. Now, in order to avoid this layer 2 loop, okay, this diagrammatically looks very simple, but just imagine if you have such interconnectivity. If you have an interconnectivity of devices like this, right, there is a high chance that layer 2 loop will obviously be created. Okay, so in order to avoid this layer 2 loop, okay, in our enterprise, we also deploy something called as spanning tree protocol. Okay, and there are different versions of spanning tree protocol like RSTP. Okay, then we have PVST, per VLAN spanning tree protocol. As I was saying, we have created different VLANs for different departments. Like I gave an example of an HR, I gave an example of IT. So just imagine them as different VLAN structures. So based on the different departments, different VLANs, we can create different spanning tree instances, right? So we will be looking into those. Uh, 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 we will be looking into spanning tree technology as well in this course as well, right? Then there is, let's say that, okay, let's take the same example where two switches are connected, switch 1 and switch 2. Okay. And we switch 1 and switch 2 are connected. And suddenly what happened is that these two devices lost the connectivity, wherein this particular interface went down. Okay, this interface is went down. There is a physical problem, and or there is an interface issue. Anything has happened, and the two switches are not able to talk to each other. So if the two switches are not able to talk to each other, of course there is a disruption in your network, and the information between switch 1 and switch 2 cannot be exchanged. So what we do is we need to create an alternate path, okay, so that switch 1 and switch 2 can talk. So what we do is we create multiple links between these two switches. We create multiple links between these two switches. So if we take the diagram here, okay, so if all these switches are connected by one wires like this, if all these switches are connected by single wires, so if let's say that the top device, okay, or let's say that the top device, okay, this device goes down, it's not working. Okay, so what will happen is that so what happens is that okay, sorry about that. So if the top layer has single connectivity, right, and if the single connectivity goes down, what will happen is that any device that is connected to this switch, for example, there are multiple devices that are connected to this switch. Okay, so if this switch goes down, what will happen is that all these switches will lose their connectivity with the entire network, right? So your network is basically disrupted. Now, in order for that not to happen, what we do is we create multiple links between any two switches. So even if one of the link goes down, still there is a chance that the other two links will still be connected and the two switches will be able to talk to each other. This what we call it as is port aggregation, or in the Cisco's exam term, we call them as ether channels. So we will be discussing about ether channels as well, and how do we configure ether channels in such a manner. This is also what we are going to study about it. Okay. Now, what is happening is that we once these access layer switches, okay, once these access layer switches are connected, what we also forget to see that we have a different mechanism of connecting multiple access layer switches together, and that mechanism is through a distribution layer switch, where in this example, just imagine that each of these switches, each of let me use a different color, okay, where each of these switches, just imagine them as these different switches are access layer switches. Just imagine them as access layer switches, wherein they are connected to multiple end users, right? They are connected to multiple end users. This is what your typical distribution layer would look like. Now, obviously, your when if you have huge number of devices connected to each other, okay, and you want that all the interfaces, just like this, if you have huge number of devices connected to each other, and you want what you want is you want all of them to talk to each other, not just this access layer switch, but multiple access layer switches should be able to talk to each other, and all the devices connected to the access layer switches should be able to communicate with each other, and the traffic between all these devices is huge. That means you're continuously sending some or the other information between each other. The access layer switch does not have the capability to send the traffic from one end to the other end. Okay, so For that matter, you need a distribution layer switch. You need a distribution layer switch just like this one, where it is connected with a single distribution layer switch that is given here. And this distribution layer switch will be in turn connected to multiple access layer switches, right? And these access layer switches would be connected to end users, right? So what happens is that distribution layer switch has a higher capacity, has more number of ports, has a higher processing speed, okay, so that it can transfer multiple traffics flawlessly. So if we look at this in a diagrammatic format, okay, what is it? Yeah, this was your access layer switch, correct? So if we look into a diagram format, these access layer switches are then connected to a single distribution layer switch. Okay, it is connected to one single distribution layer switch. Just imagine the network complexity, wherein not just one distribution switch, there are multiple distribution layer switches. There are multiple distribution layer switches. Now, these distribution layer switches are again in turn connected to an access layer switch. Okay. And again, this access layer switch is connected to multiple users. Now, as I was saying, we need a spanning tree protocol in order to avoid layer 2 loop. You need a spanning tree protocol as well between these three distribution layer switches, and also you need a redundancy between these three switches as well. That means all these three switches should have multiple links connected between themselves, so that if one of the link fails, the other link is able to take the traffic on. Okay, then we also do some kind of routing. We also do some kind of routing between these distribution layer switches. What kind of routing or what kind of routing protocol do we deploy between the distribution layer switches? We majorly use EIGRP, Enhanced Gateway Routing Protocol. We use EIGRP, right? Routing protocol in the distribution side. Why do we need EIGRP and why not we use OSPF? OSPF majorly is deployed in our WAN side, okay, or the service provider side, or we call it as ISP. All right. Then EIGRP is majorly deployed on your enterprise side, where these distribution layer switches are not just a normal switch. They are basically layer 3 switches, where they have the capability to do layer 3 routing as well. Okay. So for example, where in real time scenario, where we will see these distribution layer switches. Okay, we will see these distribution layer switches. For example, if for example, my company Cisco has 9 buildings. Okay, it has 9 buildings in itself in the campus. Okay, so what is going to happen is each one, let's take the example of one building. Okay, one building, for example, this is one building. This one building will have many access layer switches, and that access layer switch, okay, will be connected to one of the distribution layer switch. Will be connected to one distribution layer switch. Let's say take that like this. It is connected to one distribution layer switch. So building number 2 is connected to that same distribution layer switch. Okay. Again, building number 3 is also connected to the distribution layer switch. Now, what happened? The ports or the capacity or the processing of one distribution layer switch is now over by connecting 3 different buildings. But as I was saying, I have 9 buildings. So if I need the 9 buildings to be connected, right, and all those 9 buildings also has their own access layer connectivity, right, I need 3 more distribution layer switches, right, so that I can connect 9 buildings together. So I hope you are able to imagine what the connectivity might look like. So here, if I say, so what will happen is that my let's say that building 1, 2, 3, okay, building number 1, 2, and 3 will be connected to one of the distribution layer switches. Again, building 3 to 6, building 3 to 6 are connected to the next distribution layer switch. Then building number 7, 8, and 9, they will be connected to the next distribution layer switches. And then these distribution layer switches will be in turn connected between themselves. Now, since what will happen is that let's consider these different buildings as different VLANs. If I need one particular building, one set of building to talk to another set of building, okay, I need routing. If I need VLANs, different VLANs to talk, okay, so I need different or inter VLAN routing. So if I need inter VLAN routing, I need a router. Okay, but a router is a device which has a higher capacity, has a higher processing speed, which will be basically wasted in such a small scale. Okay, so I created a layer 3 switch which has a capability of doing layer 2 forwarding as well as layer 3 forwarding. So I created a layer 3 switch and I deployed it in the distribution side, distribution layer side. So my devices, all the access layer devices are connected to the distribution switch. And since it has a capacity of doing routing also, and I can deploy inter VLAN routing. Okay, so forget VLAN for now. When I'm talking about routing, I use EIGRP. Okay, when I use EIGRP, it is much more scalable in a small network. EIGRP is not scalable in a larger site where you have 1,000, 10,000 devices connected to each other. That scalability is only possible with OSPF. And hence, in your enterprise side, we will always see EIGRP. So again, in this course, we will be learning how EIGRP achieves that kind of routing, not just from the enterprise side, as well as we will see in general how EIGRP basically is deployed and how multiple layer 3 routing forwarding can be done using EIGRP. And when I say layer 3 routing, okay, it encompasses layer 3 switches as well, and it encompasses routers as well, both. Okay, so they can do EIGRP. We will be learning about EIGRPs as well. Now, next layer is the core layer. Okay, so imagine this, your distribution layer switches. Now, let's say I have connected multiple, let's imagine that my campus is a huge campus. So my campus is a huge campus. All right. Now, not just it not only has Cisco company, it has many different companies. For example, Amazon. It has Amazon. It has uh, Google, whatever Mang or Fang companies that you can think of. So if I am, this is the, let's imagine that this is the Cisco network. This is the Cisco network. This side is the Cisco network, right? Now I'm still inside a huge technology park. I'm inside a huge technology park. So my Cisco devices, okay, it's not that I cannot talk to any person in the Cisco and a Cisco employee cannot talk to a Google employee. It's there is no such restrictions. Have you ever seen such a restriction? No, right? So obviously that means Cisco campus can talk to any devices in the Google campus. So obviously, what just imagine the Google campus will also be connected to different distribution switches. So let's imagine that this is the Google campus. Okay, Google campus also has its own distribution switches, different distribution switches, right? And in turn, this distribution switch is connected to multiple access layer switches, right? And then this access layer switch is in turn connected to different users, right? So this is the Google campus, and not just a Google campus. Here you have, let's imagine that you have an Amazon campus as well. Okay, not Amazon campus, Amazon's building as well. So Amazon has its own building or set of buildings, right, who have their own distribution switches. Now what will happen is that again these distribution switches are in turn connected to one single core switch. Okay, here instead of talking about switches, we should call that as a router. We should call that as a router. Okay, so here in the core side, we always deploy a router because, as I said, router has a higher capacity, has a higher processing speed. Just imagine with the 9 buildings, I will always in the Cisco campus, we will have more than 5,000, 6,000 users in the 9 buildings. So similarly, Google will have 9,000, 10,000 users. Amazon will have 9,000, 10,000 users. So their traffic, okay, just imagine the amount of traffic that these guys will be using or sending, right? So the router or any device, not a router, I would say any device that has a capacity to handle that amount of traffic should be deployed in the core layer. So your core layer will be having a router because router has a higher capacity. Now, as I was saying, let's say that this is one single IT park. Okay, this is one single IT park. Okay. Now, if I want this IT park router, okay, obviously, like this is a huge city. Okay, let's imagine that it's Mumbai city. So Mumbai city not only has one IT park, it has multiple IT parks. And one of the IT parks, in one of the IT park, this is the router, right? So just imagine that if this core layer router wants to talk to any other IT park in Mumbai, so what will happen? It will also be similarly this particular. Give me a minute. Okay, so just imagine that these are different core layer routers. Okay, these are different core layer routers. Okay, so again, just zoom them in. Okay, you'll find these core layer switches are connected to distribution layer switches. Then these distribution layer switches are connected to access layer switches. Okay, so again, in your core layer also you need redundancy. You need that these core layer switches can talk to each other. So when we are deploying, when we want these core layer switches to talk to each other, we deploy something called as OSPF. We deploy OSPF. Okay, so there we, in our course also we will be learning OSPF. Okay, we will be also learning OSPF version 3 as well. So we will also see how and where do we deploy OSPF. Okay, then let's imagine that these multiple core layer switches, okay, are then connected to a big end router. For example, all these core layer routers are, let's say that there are 10 core layer routers. Okay, just imagine that there are 10 core layer routers in the Mumbai city. Okay, and they are taking your traffic and distributing the traffic across all the users. Now, what will happen is that the Mumbai city will have one particular router, which will be a very, very powerful router that is then connected to, okay, this is the end router. This is my end router, okay, and that is my Mumbai city's router, through which all the traffic would either would be entering or exiting the Mumbai city. Okay, and the Mumbai city will not just have one such router. Okay, it will have many other routers. Okay, now what will happen is that if if I want these different routers, okay, if I want these different routers, this is the Mumbai city router. Now let's imagine that I have a router in the Delhi side. Okay, this is the Delhi side's router. Now if I want these two routers to start talking with each other, if I want these two routers to start talking with each other, I need some mechanism, right? OSPF, EIGRP, RIP, no, these are not going to, these are not sufficient. These are not sufficient to take that amount of traffic from one end to the other end. First, the reason is that OSPF, EIGRP are not that scalable. Okay, they are not that scalable. So if I need scalability, wherein a particular routing protocol that is able to accommodate that amount of traffic, that amount of IP addresses, that and it has a lot of dynamic inside it, uh, where I can manipulate, the traffic source, where I can manipulate the traffic destination. Okay, all those things. That is what you call it as scalability. So if I want that scalability, EIGRP does not provide me that particular scalability, because EIGRP, how it works, it works on some kind of cost or a metric. Okay, we call that as a metric, and that metric is basically the delay, okay, and bandwidth. Similarly, OSPF just works with the bandwidth. Okay, based on the bandwidth, it tries to find out the least shortest, or it finds out the shortest path to reach from one source to other. But there is one more protocol which is even more scalable and not only uses the bandwidth, it has so many other criteria, and that particular protocol is BGP. Okay, BGP has seven, not just seven, it has multiple metrics or path attributes. I would say path attributes. We will learn all in this course as well what is BGP and how BGP is able to scale with so many routers, and why BGP is deployed in our WAN system. Okay, so we will also learn about BGP. Now, so if two routers here in the Mumbai side and here in the Delhi side, right? If these two routers want to talk, we usually deploy BGP. So we'll be learning about BGP as well. Then what we are going to do is, again, just visualize that this city router is connected to a core router. This core router is in turn connected to a distribution switch. Then this is connected to an access layer switch. And then this access layer switch is connected to multiple users, right? So this is what your enterprise. Okay, now when we are talking about enterprise, our enterprise network, when we talk, it is up, it is limited up to this side only. Okay, it is limited up to this side only. Okay, when we go about, we are learning BGP as well, right? BGP is not basically not deployed on the enterprise side, but it is good to learn about BGP as well. So that is why we have BGP in our ENCOR and NRC as well. So BGP is always deployed on your service provider or wide area network side. Now, this is all about wired services. Okay, now let's just zoom in. Okay, back to the floors, your individual floors in the building. Now, when we are talking about these individual layers of building, okay, we these all now what we have looked into is about the how multiple devices are connected and where what kind of protocols that we are going to use. Okay, but with that, okay, so whatever we saw was all from wired point of view, right? So in your company, not only there are wired technologies, you will also have wireless technology. Of course, when you car connected, when you use laptop in your floor, you do not use an ethernet cable to connect your laptop, you use a wi-fi, right? So we will be learning about wireless, especially the wireless connectivity, right? That is called as 802.11, right? This is the wireless standard. We will be learning about wireless, how different wireless devices are connected. And once we learn how wired devices are connected, understanding how wireless connectivity is done, it's also very easy. Okay. Then along with that, we also need some kind of priority. What I mean as priority is that, let's imagine let's imagine that you are on a road. Okay, you are on a road, you're standing, or you are stuck in a traffic. Okay, this is the road. Okay, and you are stuck in the traffic. Not just you, there are many vehicles with you. You have buses, you have trucks, you have cars, cyclists, and motorbikes, lot of things, right? You are stuck in a traffic, right? And this is the direction that you're going. Suddenly you realize that you have an ambulance behind you. You have an ambulance behind you, right? And what does the ambulance do in order to make way for itself? It starts to use its sirens, and also it starts to blow horns, right? So using these two features that is provided to the ambulance. Okay, ambulance has the freedom to use siren and horns at any time. Using these two features, what does it do? It makes a way for itself to cross the traffic, right? So what happened is that your ambulance is basically a priority traffic, correct? Your ambulance is basically a priority traffic. Priority meaning that not just ambulance, there are other priority vehicles in your real time scenario. You have ambulance, right? You have police vehicles, right? You have fire engines, okay, and you have vip vehicles, they are also priority traffic, right? So they use these, they have these features. They have, all of them have a siren, and all of them have the freedom to use horns whenever they want, right? So they use them, and they make way for themselves in the traffic. Okay, now what happens is that similarly in your networking side, we also have such priority. We also have such kind of priority, which in computer networks we call it as QoS, or quality of service. Quality of service, right? So using the quality of service in we'll learn about quality of service as well in the course. So using this priority features, okay, I just gave an overview of priority. Okay, it's a high level overview, but when in computer networks, when we talk about quality of service, it is basically like what kind of priority you give them, priority bits. Okay, you give them priority bits because during congestion in your wire, what happens is that the priority traffic is never disrupted. For example, again, I'll give you another real time example. Okay, we say that my internet speed is 200 mbps. Okay, that's my speed. Someone says my internet speed is 150. Someone says mine is 100. Someone says mine is 50. The other guy says mine is only 20. Okay, so to get a 200 mbps speed of internet, you would have obviously paid more. Okay, so as your speed increases, or right, the internet speed increases, your cost also increases, right? The guy who is using 20 mbps would have paid less. The guy who is using 200 mbps of internet, he would have paid more, right? So now just imagine that sometimes you would have seen you are, let's example, you are watching Netflix. Okay, you're watching Netflix, and suddenly what happens? Okay, you're watching Netflix. Okay, and suddenly the your video freezes and it starts to buffer. Right, it starts to buffer. Right, probably someone who has paid a higher amount. Let's say that you are using 100 Mbps of internet. Okay, you are seeing this buffering, but the guy who has paid more amount, that is 200 Mbps, he has paid more amount, probably he might not see this buffering at all. Okay, this buffering you are seeing is because of traffic congestion. Okay, traffic congestion in your internet. So during traffic congestion, you are seeing this buffering. But the guy who is using a 200 Mbps speed, in his contract, it might be said that when he, if during congestion, a person who is using 200 Mbps speed of internet, he might not see this traffic congestion because he has paid more. So he is priority to us, right? So such kind of priority, how you can manage your traffic using such quality of service, we will also learn that in our enterprise network as well. Okay, now along with this, just where is the diagram? Along with our quality of service, okay, we need some kind of security as well in the network, because you are connected to the internet and you are connected to different devices in your system itself, your company itself. You need some kind of security, right? You need some kind of security, that so that your devices are safe, your internet is safe, your internet browsing is safe. If you are trying to uh, uh, if you are sending some information, no other person can listen to those information. We need such kind of privacy, we need such kind of integrity of our traffic. So we need some kind of security as well. So we will be learning about security in the enterprise course as well. Now coming to the last one. Okay, most of us in our company, obviously, is there anyone who is working in NOC in their company, Network Operation Center, or TAC, Technical Assistance Center? Or they will know, or even if you are not working with NOC, or even if you are not working in TAC, if you are trying to access, right, if you are trying to access your customer device, when you try to access your customer device, I'm shorting that to CD, customer device. Okay, what will happen is that you, when you log into your customer device, you basically are logging through a software. Okay, you basically log in through a software. Okay, that particular software is the your customer network software. And then what you will have is you will have access to different routers. Their names would be given. The moment you click on one of the routers, it will give you the router specification, like what is the router IP. Okay, what is it an OS, has OSPF been deployed? You will also find your OSPF information also, right? If it is an EAGRP, you will also find the EAGRP connectivity, right? And any information related to EIGRP or OSPF, like what are the OSPF neighbors, what kind of OSPF configuration we have done, all such information you can find that on your tool. Okay, so earlier when we were trying to deploy a network, deploy an infrastructure of different routers and switches, we usually used to manually go to each of these sites and log in using a computer, and then using a putty we used to log in into these devices manually. Okay, so but now what we are doing is we do not have to go to the physical location of these devices, be it an access layer switch, core layer switch, or distribution layer switch. We do not have to go to these locations, physical locations. What we do is we do a remote login. Okay, this remote login of devices on your access layer switches. Okay, this remote login of devices in your access layer switches.